Hi everybody, welcome back to Hey Chem. We are on our 4th episode and it is all about reactions. I think this episode is pretty important to have because when students approach balancing equations for the first time, they can get a little overwhelmed or they don't really know where to start. So the main goal of today is to be able to look at a basic chemical reaction or equation, be able to balance it, and be able to kind of understand what phase changes are happening in the equation. So we are going to jump right in, and I'm going to describe the the 4 types of reactions. You might see reactions, sometimes your professor might shorten it to that. It just means reaction, no big deal. Just a shorthand way to notate it. Our first reaction can be notated as A plus B yields AB. This is a synthesis reaction. And I think the best way to kind of understand how reactions work is to use colors, because colors are kind of, I don't know, they're easy to understand and they're visual. So in this case, you could have red could be A and blue could be B, and the yield to make AB. Red and blue are their own separate colors, right? You know, they got their own little subset of colors, and so does purple. So we can kind of apply that to chemicals, as in we can make H2 plus O2 yields to H2O. You know, I would have to balance this like that. H2 and O2 are their own chemical identities. They have their own chemical and physical properties, but they combine to make H2O, which has its own subset of chemical and physical properties. So that's kind of how, hopefully that works. We're gonna do that for the last 4 or the last 3 or the next 3 as well. So the second reaction should look kind of familiar. Is AB yields A plus B. This is called a decomposition reaction. I'm just gonna shorthand that to decomp. And in this case, we can use the same example. AB yields A plus B, you know. And somewhere in here you could have scientists or chemists might put a catalyst or something that could lower the energy barrier. You could do a biological or chemical catalyst. You could subject it to light, to heat, to pressure, anything like that. So it depends on what you're slowly working for. Pardon my tortoise in the background too. He is still trying to find out how to get out of his tub. And there is the door, I promise you. He just has not found it yet, even though he went through it 5 minutes ago. Anyway, this is our third reaction. It's called a single replacement. Whoop, sorry about my handwriting. So if we use the same sort of idea, AB could be purple, plus C could be our last primary color, yellow, could yield orange plus blue. Right, so AB, red plus blue and yellow, A plus B and C could yield, if this was AC, you know, then we would take red and yellow, and that would just leave us plus B. B could be emitted, B could be a byproduct, B could be a spectator ion, a solute, a precipitate, anything like that. So it depends on really what you're working with. All right, and last but not least, we have AB plus CD yields AC plus BD. And this is known as a double replacement. You see that okay? Okay, cool. And in this case, we're going to use a kind of a different set of colors. AB is going to be purple plus pink. So you could have blue plus red. That could be A plus B. CD could be white plus red. C plus D. And instead of plus, it's not like you're adding them together. These two chemical species are bonded together, you know, ionically, covalently, any other kind of E bond. yields AC, so we would have blue plus white, right, AC, that would yield a light blue, and then we have red plus red, which would yield red. In this case, it would look kind of like that. Okay, does that kind of make sense where this is BD? BD. Ah, oh gosh, you can barely see that. Ooh, well, anyway, that's kind of how double placement works. And again, all of these have their own properties, physical and chemical properties. Alrighty, so moving on, those are the 4 types of reactions. We're gonna look at how to approach and solve a basic reaction. How to approach. So say we're working with the reaction SnO2 plus H2 yields SN, tin, plus 2, oops, you did not see that, plus H2O. So we're working with that equation. How are we going to approach this and balance the equation? I have 4 steps that hopefully will help us out. One is write down your reaction with no coefficients. And that's what I've done here, kind of looking at the skeleton of the reaction, just what exactly is interacting in this case. Number 2 is to balance complex compounds first. So in this case, it could be heavy metals, large ions, big, large, dense things. In this case, we'll be working with that SnO2. That's a pretty big molecule, especially with tin. Number 3 is you're going to balance your simple compounds, your numerous ones, the stuff you find in everyday reactions, like H2, definitely, water, any small gases like halogens, except for fluorine, that's pretty reactive anyway. And then finally, you're going to get rid of any fractions or charges, if any of them are ions, unless specified otherwise. Your professor might want you to leave it as a fraction or charge. Sometimes they want to see like 5 halves O2, 3 halves O2, just because oxygen itself is a diatomic molecule. Anyway, so now that we have this list of kind of some steps to go about, I'm gonna show you how to balance this equation. It's pretty easy, no worries. Okay, so SnO2, I'm doing my first step. SnO2 plus H2 yields Sn by itself plus H2O. So first I'm going to balance my my large molecules, which is Sn, my tin molecule. So the way that I approach this is that, and this could be different for anyone, so really find out what works for you. Wow, he is really going to town back there. Sorry about that, guys. On this side of the equation of the reactants to the products, I have 1 tin and 1 tin. Cool, that's balanced. We know by Newton's law of conservation of mass, there needs to be equal parts on both sides of the equation. You can't destroy or create matter. But I have 2 oxygen, and on this equation, without any coefficients, I just have 1 oxygen. So I know I need to balance those. So for now, I'm going to put a 2 there. That gives me 2 oxygen. But since I gave that 2 there, I now need to balance my hydrogen gases, or my hydrogens. 2H2 yields 4 hydrogen, but I only have 2 hydrogen on this side of the equation. So I could maybe put 2 there, and it gets me 4H. I think after that, if you check it all, it is balanced. Now if you want to go a step further, I'm going to neaten this up a little. If you want to go a step further, you can do some phase changes. We know that tin oxide is a solid, and H2 by itself is a gas. And when this reaction goes, it's going to leave tin as a solid, but it's going to leave H2O as a liquid. You know, the H2 and the O2 are going to have a kind of a synthesis reaction to make O2. Or in this case, it'd be a single replacement reaction. AC, oh, not AC. AC plus B equals, you know, B plus AC. Or you see how that works. Alrighty, hopefully that makes sense. Just as a last note, when you're writing with ions or things like that, or cations or anions, your charge goes up here. Things like 1 minus, 2 plus, things like that. Oops. Your coefficients go here if they're standing alone. Go here. You have you need 2 moles of calcium in an equation. You need 5 moles of calcium. Here is if it is in a compound and it's affected only by itself. So it's an individual number in compound. Like SO4, it has 4 oxygen atoms, but it doesn't have 4 sulfur atoms. It just has 1. Instead, if you wrote 4SO4, you would have 4 sulfurs, and 4 times 4, 16 oxygens. Hopefully that makes sense. Just to let you know, I've run across some people who get confused about that stuff. That sort of stuff, and that is A-okay. Okay guys, thank you so much for watching. Hopefully this was helpful. If you have any questions, comments, or feedback, please drop them in our comments. I'd love to see what you guys say and answer any questions that you have, or at least talk chemistry with you. Be sure to check us out at heychemistry.com and our YouTube channel, and we will see you guys in the next episode. Thanks guys, bye.